Okay, so we're going to go over how to graph some rational functions that are a little bit more complex than what we can graph by hand. So you have that green handout I gave you yesterday. And so we're looking at those rational functions, which means that we have fractions. So we have a function on the top and a function on the bottom. And so when I look at those functions, the function on the top, we're going to refer to the degree of that function as the degree of m. And the leading coefficient will be the LC, we'll call that A. So just some notation. So the degree of the function on the top, m, the leading coefficient, so that's what LC means. So leading coefficient, didn't give myself enough room, will be A. On the bottom, the degree of that function will be n, and the leading coefficient will be b. We'll get to that when we get to the next or the back of that handout. Now, when we're looking at this, there's some things that we want to look at and we want to be able to do by hand, and then things we'll look at when we use Desmos. We want to be able to know where the x-intercepts are, because that's what we use to solve functions. And then we want to be able to know where the asymptotes are. So there's going to be vertical asymptotes, and there's going to be a horizontal, at most one horizontal asymptote. Sometimes there aren't any. And so when I'm doing this, I need to be able to, there's that word, I need to be able to factor both the top and the bottom. So the x-intercepts are the zeros of the top of the numerator, the top of the function. And so that's where we're going to solve. If I want to solve this, if I want this whole thing to be 0, well, think about it. If I have this fraction, if I have, just put a over b, if I want a fraction to be equal to 0, I need the top to be equal to 0. So that means I need the top of the function to be equal to 0. So I want to be able to find the zeros of that function. So I need to be able to factor it, set it equal to 0. The vertical asymptotes happen at the real zeros. So notice we're talking about real, and so no imaginaries, of the bottom. So that's because vertical doesn't exist. And so think about that. That's where this, the bottom, the denominator, is going to be 0. And that's because when this is 0, it's undefined. And so that's going to be, it's going to get closer and closer to that, but it's not really going to happen. And then, at most one horizontal asymptote. Where's the horizontal asymptote? Remember, horizontal means we're talking about y equals something. So we can't really get that from either of these. So that's where we flip over to the back of that handout. That's where this part comes into play, the degree of the numerator and denominator, and then also the leading coefficients. These are the cases we're going to have to memorize, and they're based on the degrees. Remember, the degree is the biggest exponent. So when the biggest exponent on the top is less than the biggest exponent on the bottom, then there's one horizontal asymptote, and it happens at y is equal to 0. When the degrees are the same, there's still 1, and that horizontal asymptote is y equals a over b. Those are those leading coefficients. And then when the degree of the top is bigger than the degree of the bottom, there is no horizontal asymptote. So we're going to figure out these 3 cases by hand, and then we're going to use Desmos to graph it for us, make a sketch. All right, so here's the first one. Y equals 6, and then we have it's over x squared plus 1. So we're going to take 1, 2, and 3. This is going to be the x-intercepts. So the x-intercepts, we take the top and set it equal to 0. Well, that doesn't make sense. So that means there are no x-intercepts. Then we're going to take the bottom and set it equal to 0. So x squared is equal to -1. That's going to be imaginary. Now, let me just put I made that I like imaginary. So that means, we don't care about that. So that means no vertical asymptotes. And then we look at the degree. So what's the degree of that numerator? Remember, when there's not an x, the degree is 0. The degree down here is 2. So when I look at that, I read it up and down. So the degree is less than 2. So I go back and I look at my cases. That would be this first case. So that means y equals 0. And that would be my horizontal asymptote. And then, I had it here, we'll pull up, inside this, we'll pull up Desmos. And here it is. We'll look at what that graph looks like. So we might have to zoom in or out. So let me zoom here. And there it is. So when I look at that, and I go back over here and I make my sketch. So there it's going along. It's got that little hump. And look, there's that asymptote along y equals 0. And so that's the only thing I was really seeing. It doesn't have a vertical asymptote. It doesn't have any x-intercepts. Let's try another one. This time I've got y equals 2x squared over x squared minus 9. Anytime I can factor, I need to factor. So this is something I can factor. Difference of squares there. So x plus 3, x minus 3. That's the first thing I want to do is I want to factor before I go and I list my 3 steps. So those 3 properties. I like to number them. You don't have to. And I think of it, okay, I'm going to set the top equal to 0. I'm going to set the bottom equal to 0. And I'm going to do it in that factored form. And then I'm going to deal with that last, but I know that's going to be where I have to think about those 2 cases. So here, that just means x equals 0. I do need to label it. I want you to label it, so x-intercept. Here, we're going to say x equals negative 3, x equals 3. You could write it as plus minus 3 if you want. Whoops, put an equal sign in between. And so those are your vertical asymptotes. So see that you need to label them because if you don't, I don't know which one is an intercept and I don't know which is a vertical asymptote. Then let's move this down farther. Now I need some work here, whether I see it up here or down here. So I'll show it up here. The degree is 2. The degree is 2. So that means they're equal. So let's go back to those cases. When they're equal, oh, it's this one. So I also need the leading coefficient. The leading coefficient of the top is 2, of the bottom is 1. So it's 2 over 1. You always want to reduce, so the leading coefficient, or sorry, the horizontal asymptote is y equals 2. Let's see what the graph looks like. So I'll uncheck this one, click this one back. Well, that's kind of funky. Let's see. So we should have had x-intercepts at 0. Looks like there's one at 0. And then let's see, here's a vertical at 3, a vertical at 3, and a horizontal. Where was that horizontal? The horizontal was at 2. And look, here's that at 2. This one doesn't go up to it, but yeah, that's getting closer and closer at 2. And so on my paper, you guys are doing this, what I would see is I'd see this, I'd see a sketch like this, I'd see those 2. Let's come back here. I'd see these 2. And I would like you to draw in that horizontal asymptote. And I'd like you to draw in, maybe a little bit better than me, those vertical asymptotes. On a quiz or a test, we're just going to do these 3 things because you're not going to be using Desmos on a quiz or a test. Let's try another. All right, so maybe pause and try this one on your own. This is one we're going to want to factor. I didn't leave myself enough room up there. So it's going to be x plus 4, x minus 1, then x minus 2 on the bottom. So see if you can get those 3 things on your own. This is going to be x minus 4. Whoops, it's not. X plus 4, x minus 1 equals 0. So x equals negative 4, x equals 1. Those are my x-intercepts. This is going to be x equals 2. That's my vertical asymptote. Then let's see, your degree is 2, your degree is 1. So that means, oh, this is greater than. Go back and look at my list, that means no horizontal. Well, let's write it a little bit better. No horizontal asymptote. So hopefully you got that. And then let's see, we'll uncheck that. Come on. Uncheck that. Check this one. Whoops, didn't uncheck that. Oh, there we go. And so let's see. We have x-intercepts, those two. That looks about at 4 and 1, or -4 and 1. And let's see, we have we had no horizontal, vertical at 2. That looks about at 2. And so I'd make a sketch. Let's not worry about graphing anything else. Let's try just a couple more where we're going to do the solving. Let's skip that one. Let's do this one. So pause it, give it a try on your own. So let's see, I'm going to factor that x minus 3, x plus 1. Not too hard of factoring problems. X minus 4. So we're going to have x minus 3, x plus 1. So we're going to have 3 and -1. Those are going to be our x-intercepts. X minus 4. So that means x equals 4 is our vertical asymptote. And then, okay, let's see. This is the tricky part. The degree is 2. The degree is 1. So that's greater than. Greater than, that means there is no horizontal asymptote. Let's see. What else did I have here? Let's do this one. 3x squared over x squared minus 9. So I could factor this, x plus 3, x minus 3. And so I'm going to have, for the first one, 3x squared equals 0. That means x equals 0 is your x-intercept. I'm going to have x plus 3, x minus 3, plus or minus 3. Those are going to be your vertical asymptotes. Let's see. So the degree is 2. The degree is 2, so that's when they're equal. That's when you got to go to your leading coefficients. So it's 3 and 1. So it's 3 over 1. Just read it up and down. So it's 3. That is your horizontal asymptote. All right, I'm going to pause it there, stop it there, and I will give you more directions in the Google Classroom.